Algebra Lesson 1-5. Continuing more in-depth coverage of our problem-solving strategies and using equations, inequalities, possibly expressions. We start off with our mathematical model. And a mathematical model, so we're thinking about math, and a model is something that might represent another situation. An expression, an equation, or an inequality that represents a real-life situation. So we're not just dealing with the equations anymore. Now the equations are going to be more real-life. For example, distance equals rate times time is a real-life mathematical model. It is an equation that represents the relationship between distance, rate, speed, and time. All right? And there's many others. All the formulas that we have for area, volume formulas, the Pythagorean theorem could be used in real-life applications. Any of the formulas that we have basically been generated because of these mathematical models in real-life situations. So to start with, we look at the mathematical model and what it begins with, and we have, first thing you need to do is write the verbal model. So you're going to take whatever is here, whatever's happening, and you're going to try to write it into words. If it were the distance equals rate times time, you would use the words distance equals rate times time. You're using words to create the situation that's here. And this sometimes takes a lot of practice. Maybe this isn't something that you get right off the bat. You might write the verbal model, start to work through the rest of the problem, and realize you made a small error, and then want to go back to your verbal model and make some adjustments. That's entirely possible. After your verbal model, you want to assign labels. So you want to look at the problem and ask yourself, is there anything I know? Am I given the distance? Am I given the speed? Am I given any kind of time frame? If you are, then you can use those values in your verbal model. If you don't know something, though, if you're looking at it going, I don't know the time, then use T for time. If you don't know the distance, use D for distance. If you're dealing with simple interest and you don't know the principal, use P for principal. Whatever piece of the problem that you've created here as a verbal model that you don't know when you're assigning labels, you must substitute in a variable for that value. And from there, you can then write your algebraic model. So you're turning the words into math. Going from something with actual letters of words, might still have letters over here, but the letters are just variables being placeholders for the parts that you didn't know when you were assigning the labels. Okay? Now, if you were to actually look on page 34, you would find the problem-solving plan. And I'm curious if you looked at it, how you would know if it differs in any way from this mathematical model. I think what you would find is that the only difference is it has two more steps. One step being that you solve, and then the second step being that you check. So maybe you start with your verbal model, assign labels, write your algebraic model, and you solve it, and you realize after you check it that you made an error. Well, you either made an error when you were solving, or you might have made an error back here, and you really need to analyze your work and decide if I set things up right. Maybe the unit analysis needs to be checked. Maybe you had something set up incorrectly so that the values actually don't cancel out the way they should. There's a number of things it could be. But really, starting with in words, try to figure out what's going on in words and start replacing your words with what you know, things that you don't know, put in a variable, and go from there. If you need to rework it, move back and start again. Don't erase everything. See if you can tweak it a little bit, and you'll probably make up a pretty good difference if you do that.